Welcome to the security module. In here, we're going to start talking about how to secure an application and what types of mechanisms we can do to create a nice and secure login page. So I'm going to go on in this module with a really quick overview of what is going on behind the scenes. So I'm going to start off with a very basic thing. Well, when we have a server or a web application, we most of the time we want to secure our resources and restrict access and present the user with some type of login screen so that he or she sends us his or her password and their login. The server will later check in its database to see if it has these credentials, if it recognizes the users, and then promptly grant access into the system. So I'm gonna create a really quick example here and enable our past application, um, the security in it. So I'm gonna move over to the database right here, and I'm gonna create a new table. So I'm gonna call this users. So I want to start off putting ID users. I'm using users in plural because I believe user is a reserved word. So I'll just name this table ID users. The type is going to be an integer, length 11, not null. I'm going to make that a primary key, auto increment unsigned. And I'm going to put the name of user. That'll be a varchar. 64 is enough, not null. And I want to ask for the login, and that will be the same. Password, I'm going to leave it as a varchar. Right now I like to use this as a char 64 because I use a hash, but we're going to get into that in a little bit later. So for now this is going to work, and we'll put a role, and I will also set that as a varchar, maybe 32. Okay, so I have a ID of the user, the name of the user, the login, the password, and what role we're gonna be setting this. But we're gonna talk about roles in the next module. So I'd like to have this ready to go. So I'll save this table. I'm gonna call it users. All right. So I'll go to Studio, and I know this isn't 100%. How could I say this? The best way to do this, but in my personal experience with this version of Studio, if I use the re-import module, I might get some errors. So what I do is just I recreate the whole database service. So just be advised, this could really mess up your grids and your live variables if you're using any. So I like to go onto the main page where I don't have any of those widgets before changing their data sets, because they're dependent on the database security. So I'll just go ahead and delete it and re-import it so I can have my users table in here. So root and sales, I believe. Yes. So sales DB is invalid. Apparently it did not delete it properly. Okay. Now it did delete it. Root sales. All right. Never. Okay, so now I have a fresh new mapping of my database, and now I have users in here. Okay, ID users, name users, login, passwords, and role. Perfect. So I can go over to the services panel, click here on security. Now we have many security providers in here. The demo was the demo out of the box that comes with Studio. Database is the one we're going to use. LDAP and Active Directory, if you have that sort of infrastructure in your company, well, you might as well know how to use this, and central authentication system. We're just gonna stick to the database in this overview. So I'll just click on this one. I'll click here on the checkbox to enable security. I won't be using SSL. More on that a little bit later. And obviously I want to see the login page. So the data model I'm going to be using is going to be SalesDB. That's the only database I have mapped in here, but I can have many databases if I need to. The entity is going to be the table users. The username field, I'll just call that login. The user ID is going to be ID users. The password field is going to be password. And the role field, we're going to leave it in blank right now because I'm not going to be using roles now. So I'll go ahead and save that. Now when I click on run, and go to the application and reload it, I have a login screen now. Now I won't be able to log into my application because my users table is empty. So if I try admin, I'm gonna get an invalid username and password. So let's go ahead and make a user here. We're gonna call him Jolly Roger. Login is gonna be admin, and password is gonna be admin, and role is gonna be admin. Okay, very easy to guess. But now I have the login and the password, and we're gonna talk a little bit about password security in a moment. But right now, let me see if the transaction is committed. Yep. Now if I put admin, I have successfully logged in. Now I have to add a logout variable because right now the user has no idea on how to log out the application because I have to add it. So let's go ahead and do that real quick. So to add a logout button, we're just gonna add a new button here. btn logout. I think it's 130, 120. I'm going to add a little icon here, and I have to go insert advanced logout variable. So this logout variable is the one that's going to eliminate the session. So all I have to do is events on click. Whenever I click on this button logout, I want to refresh the logout variable. So let's go ahead and try that. Okay, I'm gonna try to put a phony user. I can't log in, but if I put the one that's in the database, I can log in, and then I will log out. I'll put a bad password. Great. So the application is working. I can also add a small welcome message using a service variable to get some credentials. So I'll use that right here. I'll go to my splash screen. You can also see the login page right here. We're gonna get that in a moment. But let's go to the splash screen, and we can also insert a service variable. We're gonna call that SRV get username. So the service is going to be security service, and now we're not going to use CAS. We're not using tenancy, but we can get the user ID and the role. So let's try get the username. So we're gonna change our message here. I'm just gonna cut that out and use this expression editor here. I'm gonna paste this. Welcome. I'm gonna do a small concatenation here. And I'm gonna use the data value here. So I clicked on the SRV username and I put the data value in here. So welcome SRV username dot data value to the POS application. Bind it. And I'm also going to make this variable. Right now this variable is owned by the page. I'm going to make it to be owned by the project, and that I can just change it right here, so that all the applications, or I mean all the pages in this application, can access this service variable right here. So if I go back to the main page, save, I can also see that the get username is available for everyone. I'm gonna also do that with the logout variable. Let me change its scope to the project. Now this service variable is going to start update, but I've had a little issue with this throwing some type of error when the screen is loading because its scope is set to the project. So what I typically do, I like to do it on the page load on the main. So right here I will refresh this variable. So I do that just by putting app. You can see that I'm not using this because this refers to the page. It's this page, but app means the project. So you can see right here app dot srv get username update. So that will refresh the service call, get the login, and then when this page loads, in this concatenation here, right now it's showing null, but it will see, you can see it, Studio automatically changes. It's gonna put the value in there. So let's just go ahead and try this. Okay, let's refresh our page here. Let's put our password of admin. Let's log in. So it's now saying welcome admin to the POS APPL. I'll just have to resize this a bit. Give it 350 pixels. But it works great. I was able to get the username to customizably say welcome user to the application, and the logout is working fine. The demo worked out pretty well. So what is happening behind the scenes? So in our client side, in our browser, we're putting username and password admin, and these credentials are sent to the server. So when the server receives this, it queries the database looking for this information and retrieves it, and it later compares to see if this user, admin, and password is a match, and in this case we do. So if there's a match, our access is granted and we can go into our application. So what about the clear text passwords? So I think it's pretty straightforward. We should never store passwords in clear text, and the way we can fix that is using hashing. So what is a hashing algorithm? So a hash is a one-way function. What do I mean with a one-way function? We have a string of text admin, and we'll run a hash algorithm, and the hash will produce this long string of text. It's one way because admin will produce this string of text, but this string of text, there's no function that will revert this to admin. So it's good because it's used as a signature to compare file integrity, and it also produces a fixed size. This algorithm that was used, it was SHA-256. It's the one we're going to use later on, and it always returns, I believe, 64 characters. So even if I put AD instead of admin, I will receive 64 characters, a totally different signature here, totally different string. Or if I put admin1, it's going to be a totally different string, but it's always going to be 64 characters long. And the hash is unique to that input, so that is I put a little asterisk here for two reasons. One, it means that every time somebody writes admin, this is the output that's going to produce. So that's kind of a vulnerability, because if we have millions and millions and millions of pre-calculated hashes, we can compare if this was produced by admin. So that's where salts come in through. But we're gonna that's the third topic. And the other point I wanted to talk about this, that it's a unique to that input, is that depending on the size, because this is 64 characters long, if it was shorter, like MD5, which is another hash algorithm, or a simple checksum or something like that, the size of this hash is smaller. And when the size is smaller, there is a possibility that another string of text or another file would collide. So that is not good. So a larger size means more processing, but a much lower chance of having a collision. But SHA-256 is pretty good. I think there's a chance like in millions or billions, 1 in a billion chance or something like that, to have a collision. So we're pretty secure on that. So I'd like to show exactly how this signature to compare file integrity works. So here I have a text document. This is the complete works of Shakespeare. It's 5 megabytes and it's pretty big. So I'm going to copy it. Just going to copy, paste. Okay, so I have the copy and the original. And I installed in my computer a little tool called Hashtab. So what Hashtab does, it automatically calculates the hash of my file. This one's using SHA-1. It's pretty good. And it gives me this signature. And if I want to compare, where's my copy? This is the copy. To the file, the copy will also be run into the hash, and then this hash and this hash are equal. So it's telling me that this file is exactly the same. And notice that it's 34A5, this number, it starts with this, and it's all these characters have to match. So let's go over to the copy and change a single letter. So let's go and let's look for this quote here. Cry havoc and let's slip the dogs of war. So I want to add one exclamation point to the word havoc. I'll save that. Now the files are very similar, but right now they're completely different because of that single character. So I'll go ahead and go to properties. I'll compare it to the file again, and now look at the signature. It has completely changed. It's C242BBB, and the original file is 34. So you can see, just by adding one character to a document that has 124,000 lines of code, one extra character changed the signature completely. So these hashes are really, really good for comparing if something is equal or not. So that's what I wanted to demonstrate. So just remember, a single character change, just the signature or the calculated hash is completely different. So these files are no longer the same. So how do we use that in our login? So what we're going to do is we're going to get the password and we're going to put it in a hashing function, and we're going to produce this long string of text. We're going to send that over the network, because also if somebody's eavesdropping and they get this hash, they won't be able to put admin in the password field. All they will see this, they would have to have a pre-calculated hash cracker or something in order to see it. That's why they ask users to put special characters, because special characters and like dots and these funny symbols make the hash calculation even stronger. So admin is a really easy password to calculate because it's just very humanly readable. But if we put admin quote exclamation xvga whatever, this hash is going to be pretty secure because it's not going to be pre-calculated. So the database is not storing the hash. It's storing. I mean, the database is not no longer storing the clear text. It's storing the hash. So this is what we're comparing right now, and it's a much more secure way. The downside is that if we're just using the hash function, all the users that have the same password will have the same hashes. So if somebody breaks into the system, they will be able to see that users have the same hashes, so they'll know that the users have the same password. So that's where Salt comes in. But I'm just going to go over Salt real quick, but we will not be using it on our application right now. So going back to the thing I was talking about, that all users have the same password. So if the user puts in admin, they're going to get this signature here. If a user puts admin and I add a random string of characters, they're going to have a different password. And if I store this random characters, which is the salt, into the database, I'm gonna be able to correct that error. That if a second user has admin as its password, I will have a second set of random characters that is concatenated, and now the two hashes are completely different. So even though the user has two users have the same password of admin, their hashes are completely different. So if an attacker breaks into the database, they will be able to look at this, and I don't think they'll be able to calculate the hash, because this makes it really complicated, and the password is really well secured. So here's another third example. If there's a third user, you can add on a string of text and use that. So it's basically running the hashing function with an extra random set of characters, but we're not going to be seeing this. So the good side about this is that users with the same password have different hashes, and this by itself, these special characters and this random code, makes the password really hard to guess. So we're gonna always storing the passwords in a hash, but we're also storing the salt. So the match tells us that the access is granted. So we're going to implement a hash password, and we're going to be using Crypto.js. So you can go into this website to download it. I believe I have it open here. Okay, so I'll go to this website. I'll go to downloads, and I'm going to use the latest version of Crypto.js. I'll download it. I'll just open it with WinRAR. So we have a lot of hashing algorithms and cryptography tools in here. We're going to be using SHA-256, the secure hash algorithm 256. It's a pretty secure one. I'm going to use the minified version of it. It just makes the browser. These two files are essentially the same one, but this one is a little bit more compressed because it takes away the lines of so the browser just loads it a little bit faster, this minified version. So what I'm going to do, I'm going to use this JavaScript file and copy it over to my, where's the application? application resources folder. Okay, so here in our project folder, we're in app sales, web app root, resources, and we can put external JavaScript libraries in here. So I'm going to copy this guy in here. Okay, so if we take a look at this, you're going to see that the minified version, it has a pretty complex algorithm in there. So in order to load this file in here into our login page, I'm just going to import the JavaScript library directly into my login.html file. So I'll go over to web app root, login.html, and I'm just going to load it right here. So let's go ahead and put scripts type equals text JavaScript source equals resources resources JavaScript sham check resources JavaScript sha256min.js. Okay, so adding this tag in here to my login page will import this JavaScript library. So I'll save it. And I'll rerun my application. Okay, so not much is going on right now. The library is supposed to just be loaded in here, but it's not going to be doing anything. So I'll just make sure the library is on just by opening Firebug, and the library should be able to appear here, but it's not. I'm not seeing it. Yep. Okay. I think I wrote this properly. Maybe there's a core inside the library. Yep, there is a core. So I think I should also import that. Sorry about that. Okay, let's import that second file here. I'm just gonna copy this and okay, coreman.js. Alright, let's try. Maybe. Okay, it's good. Okay, here it is. So now I have the crypto.js library in here because you can see it right here. Crypto.js dot. Okay. Am I missing any more? Let's take a look at the file here. I am not seeing the SHA-256 function. Oh, the order. I have to load the core first and then load the library. Okay, that should work. Okay, so crypto.js. Okay, here it is. So now I have a hashing algorithm, and I can put the string of text admin, and I'll just show that into a string. Okay, here it is. So I input the string admin, and here is my hash. So I will use this on this password field to put that into the login variable. So I'll just copy this, and I'll go over to the login page, login variable. Now the login variable has the username, password, and this hash input that we're not going to be using right now. We're going to just use the password right now to bind it. So we're going to use crypto.js SHA-256, and in here we're going to be using the password input field, data value. So our password input field data value is being fed into our crypto.js, and that is going to be sent over to the server for validation. So let's run this. Let's reload the page. Okay, I'm going to put admin. Now I cannot log in. If I put admin again, I can't, because in the post you can see that the password is the hash. I'm not sending admin. So I'm going to copy the hash and store that in my password field. Okay, so I should be able to log in right now. There we go. So if I put the wrong password, you can see that I'm no longer transmitting what the password is. And I'm just transmitting the hash, and that's more secure. And if I have the right password, the hashes will compare, and I will be granted access. So the last thing I would like to talk about is about SSL, or Secure Socket Layer. As we all know, HTTP, or the Hypertext Transfer Protocol, is insecure. So all the requests and responses between the client and the server can be easily read by some attack or some listener in any node within our network. So at least we're a little bit secure because we're sending a hash right now. So if that hash is intercepted, if they try to copy paste the hash in here, they won't be able to log in, because the hash is going to produce another hash, and it's not going to match. Only if I put admin it's going to work. So that's good. But all the other activities we do, as register a new sale, or download a receipt, or print anything, all those activities can be collected by an intruder or somebody that is within the network. So that's why we have SSL. So Studio has a really simple SSL, but I'm going to cover the basics right now. I'm going to overly simplify many things. So here's a network. Let's say this is your PC, and you're transmitting. Let's say this is your PC. You're transmitting your information over to the server. So packets are going to go hopping from this switch to this switch to this router. This router will go to the server will receive the request, will receive the response, it'll go hopping to here, to here, to here, to here. But this computer that they're on the same switch, they could be listening to the traffic. And if this traffic is not encrypted, they can know what we're doing. So that's where SSL comes in. So SSL, or it works with HTTPS with it, which means Hypertext Transfer Protocol Secured. It uses something called a public key cryptography. So there are two keys involved in this. The server provides pretty much an open box. So just picture it out like an open chest, an open box, and sends this over to the client or all of its clients because it's a public open box. And the client will put his message, his or her message in here, and this box, which is essentially the public key, will be encrypted using that public key. So now this message is locked using the public key, and not even the public key can unlock it. So it's another one-way function. We can close it, but we cannot open it with a public key. Now this secure message will be transmitted over the internet, over the network. Attackers will be able to intercept this message, but they will not be able to open it. So this encrypted message goes through the network, goes to the server, and the server has a private key. So this private key and the public and the private key are related, but only the private key is able to open that message. And this private key is stored within the server or the company's environment. It is not public. If it were to be disclosed, that would be certainly a security breach. But this is the only key that can open that locked chest that was closed with a public key. So it retrieves the message, and the server is ready to read the message. So this is really important because banks will probably use this. Well, not probably, they do, in order to protect sensitive data like credit card information or patient information. It's secured like this. The servers will send a public key to everyone. Everybody will be able to use that key to lock their information, and they'll send that information to the server, knowing that the server is the only one that has that private key that will be able to open and decrypt it and read your credit card and all that information. So this is becoming pretty much a standard right now, because we don't want eavesdroppers to be looking at what we're doing for privacy or security concerns. There's many things that can be involved here. So I'm just going to enable it. In Studio, here it comes with if we go back to the security tab here, we can use SSL. Now this SSL, I don't recommend it to use it in a production environment, because it's a certificate that is self-signed, and the browser will most likely throw an error saying about that it's not trusted. I will touch that right now in a moment. So I'm just gonna check the SSL communication. Okay, let's reload this. Oh, okay, I had previously accepted the certificate on. Okay, so let's see. Oops. All right, so right off the bat, we're getting a warning, a big red flag here. It's saying the connection is not private, and they're saying that attackers might be able to steal the information from this server because the authority is invalid. So if I go to advanced, it's saying that it might be unsafe to do it, and if I proceed to it, it will work. So why am I getting this error? So the keys that were used, the public and private keys, well, more specifically the public one, because it's the one that the browser is going to receive. The browser doesn't know who that key belongs to. The browser has a fixed list of certificate authority it trusts, but a key coming from an unknown source is very suspicious. That's why we get the warning message. So if we take a look into the key here, it says that the identity of this website has not been verified. And let's go ahead and take a look at the certificate. So the certificate was created by a certification authority that the browser does not trust, and it was issued to Sung Lee. And Sung Lee is one of the engineers that worked on the server side of Studio from VMware. So this was a personal certificate that was issued by himself to allow Studio users to implement SSL easily. So this was valid from this date to this date, and it has some hash information in there. So what's important here is that this key was generated by an individual person, and the browser does not know that individual person. That's why we're getting this error. So here's where certificate authorities come in play. These keys are tied to a specific users and domains. If the browser does not know about this user and domain, it will give us this error. And in order to avoid this error, the key has to be registered in a registration authority, and a digital certificate that is recognized by the browser and the browser trusts has to look at the certificate, and well, it costs money. So let's look at a valid certificate. Even though our communication is encrypted, and even though the browser is telling me the error, or my communication is being securely encrypted. So let's just go to google.com. Now I'm using Chrome in this example, and this browser trusts Google because it's produced by Google. So this these keys, this public key here, the browser knows it is from Google because the certificate is from Google. So how certificate authorization works and these digital signatures might be for another course. The only thing I wanted to illustrate here is that SSL is, if you want to encrypt all your traffic, use SSL, and if you're using a self-signed certificate, it's the browser just throwing a red flag saying that the certificate authority or whomever signed that certificate doesn't know about it. You can purchase these certificates by certificate authorities. It costs money. The prices vary, but for testing purposes, this certificate works fine. In Firefox, I'm not getting the error because I added the exception. I mean, I manually said it's okay to use the certificate. I trust it personally, so the browser is not telling me that the error, as in Chrome. I would have to acknowledge the security exception and load the certificate so that I don't get this error anymore. So it's a little bit about security, and this is mostly used to avoid somebody forging these keys and saying, I'm going to use this key and I'm going to try to impersonate Google and steal your information from your Gmail account or something like that. That's why there's a certificate authority that the browser trusts. So it's pretty much the top of security right now. So I've just given you a really quick overview of how security works. In the next module, we're going to be talking about roles and go deeper into the server side and validation of things. So I hope this video was helpful. Please give me your comments, and thank you.